Good afternoon, Packaging 450. Welcome to another lecture. Today we are on lecture number 14. We are in chapter 5. Yesterday we ran through the way to calculate an expendable pack because we're in the middle of doing a cost justification to determine the ROI. Oh, before I go any further, yes, I'm a packaging nerd and I'm proud of it. So I just had to show you that. Okay, back to what we were doing. So again, we came up with a cost, and I will share my screen. Okay, so we finished up here where we did a rough cost calculation and determined that over the life of 5 years of this vehicle, for this product, we would be spending $5,844,500 for expendable packaging. So we're buying expendable packaging, sending the returnable packs to the suppliers putting parts in it, shipping it to the OEM. The OEM empties the expendable pack. They get rid of the pack, whether they throw it away or whether they recycle it or compact it or whatever they might do to it. And then they have to rebuy more packaging because it's only a packaging for one use. Okay, so we did all that. We figured out all the different costs. We included freight in that. So of that 5.8 million, 1.6 million of that was freight. And remember, as things like the fuel charges change and we have driver shortages and supply chain issues, that price could go up. So you want to make sure that you include that because, as we mentioned yesterday, that could be a significant portion of the cost for any packaging, whether it's returnable or expendable, or really any part in general. To transport that part, the cost can be significant. Sometimes it can be very significant. So when we did that, we also figured out how to calculate a really rough calculation for the board, determining how much board is used, square footage. Then we also took a cost and weight, cost based on the weight of the material, figured out from the size and the type of material what that weight would be, and we were able to come to a cost estimate from there. Okay, so again, we finished that up. We came up with, again, remember that $5.8 million that we came up with for the expendable. So keep that in mind. We'll come back to that. So again, we just wanted to do a rough estimate. Next, our next step in this process is to determine how much will the expendable pack cost. Because remember, this bin, we're going to use $150, I believe, for the bin. Yep, so the cost per bin is $150. So you think, I think it was like a $23 pack versus one that's $150, but this one will get reused. So you'll get to see the difference in the cost based on that. Okay, so we can use some of the same numbers as far as like usage of how many parts there are. We'll go through here. We know that the assembly plant is using 2,425 parts per day, which we're going to try to do apples to apples. We want to have the same usage per day and compare for the same number of parts, how many packs are we going to need, how much those packs are going to cost, and how often will we use them. Okay, so we knew how many parts went into the expendable pack. And then we also know that the number of parts that fit in the roll pack was 30, because that pack was same footprint, length and width, but it was a little bit taller. So we know we can get more parts on the truck and everything with this returnable bin. But again, that 45 by 48 by 34 roll pack bin is, you can get 30 in there. So you can take the parts per day divided by the number of parts per bin, and we get 80.83. Okay, but we're going to round that up to 81 because we know that they're not going to fill, the supplier is not going to fill the bin with a partial pack. every single bin is going to have 30 parts in it. So you're not going to get, 80 bins with 30 parts and then the last bin is going to be a partial bin. We know that that's not going to happen. So we know it's going to be full, it's going to be rounded up. So you can go to 81. So again, you're going to take the number of parts per day, the 2425, divide that by 30 parts per bin to get the number of bins in there. So we also need to know what's called the system days, right? So based on the supply chain loop, which we talked about before, we know that the bins are going to be in circulation for 9 days. So the system days is going to be this bin from the time the supplier gets it, they start filling it up with parts, they put it on the truck, ship it to the OEM brings it in, maybe they store it. They eventually, whenever they bring it to the line, the operator at the line pulls the parts out, takes those parts and puts them on the vehicle. Meanwhile, once these 30 parts are taken out of the bin, then that bin gets taken away from the line and they stage it to get shipped back. They load it on the truck and then the truck takes it back to the supplier empty to start all over again. That whole process from beginning to end, we've figured is going to be 9 days. So that 9 days in system going from the supplier to the assembly plant and back, that is the loop. The loop is 9 days. So the simple calculation that we did before for the fleet size would be number of bins per day, which was, we figured out was 81 because we rounded up from the 80.83 to, we rounded it up to 81. So we know the fleet size is 81 bins per day times the system days in the system of 9 days. It's going to be 81 times 9, which comes out to 729 bins. So now you know that over that 9-day period, from beginning to end, you're going to need 729 bins. Again, this is a very, very basic, simplified fleet calculation. It doesn't include a lot of other factors. Like I said, I'll show you some other examples so you can see that. But this is just a basic starting point. So now, since it's a basic calculation, you kind of want to add in some other things just to make sure you have enough bins and you're, on the right track. So the first thing is we talked about the contingency. So that contingency that we talked about in the last chapter of 10% for like repair, so things that, get damaged, you want to add a 10% contingency to that. And then you can add another 73 bins. So basically you're going to take that 729 times the 10%, or 10% is equal to 0.10. So I'm going to pull out my calculator and you can see that. Okay, so we've got 10% is equal to 0.1. So you take that 0.1 and then you're going to multiply it by the 729. And that will give you 72.9. Again, you don't want partial bins, so you're going to round that up to 73. So 72.9, you're going to round that up to 73 bins. So now we know that we're going to take the 729 and the 73 bins. So we know we have that repair contingency in there. Next, we have the operational reserve. So they need to have 4 hours worth of material, which is half of the shift or half of what they use a day. So you can take half, which means, since we know that's half of what they need per day because they're on an 8-hour shift. So that's another thing you need to know. So we're assuming this for this one because some plants have multiple shifts, some plants have 10-hour shifts, whatever that is, you need to understand what the reserve amount needs to be, because everybody will have a reserve, again, in case a truck breaks down, in case there's a power outage, in case of whatever, there's a bunch of people get sick, whatever happens, they need to have 4 hours. This particular plant, every plant will determine what their reserve is, but this plant needs 4 hours worth of parts in case of an emergency, in case they can't get parts into the building. So they can at least keep running for another 4 hours until they work out whatever that issue is. So the plant doesn't stop running, which again is the cardinal rule of automotive. Don't ever stop the line, right? You don't want to be responsible for that. So you put in that extra insurance. Okay, so again, we know that 4 hours is half a shift. So that's why we're taking the 1/2 and multiplying it by the 81. Because we know that 81 going back again to the number of bins that are required. So now you're taking your fleet size for 9 days of 729. You had that 10% contingency of 73 bins, and then you're adding another half day's worth of bins to that. So you can take 81, which is a day's worth of bins, 81 bins, and then half of that is going to be 40.5. So again, we're rounding up to 41. So then that brings you to taking all that again. So you've got the 729 plus the 73 plus the 41 to get 843. That is the fleet size that has been calculated that they need. So now you can look at, okay, this tells me how many bins I need to buy for my 9-day cycle for this particular part based on, contingencies, based on operational reserves, everything that they need. It's in there. So you're going to take the cost per bin, which is 150, which we talked about before, and you're going to multiply that by the number of roll packs you need, because you need 843 bins. So what is the cost to purchase those 843 bins? We know that each one's $150. So the cost to buy 843 of them, you're now spending $126,450. Okay. So let's go back and look at the expendable. So for what we're buying for 9 days, which we plan these bins are made to last for the life of the program. So they're assuming that for the life of that vehicle program that's being made for 5 years, these will remain in good condition. They won't lose that many. They've got that 10% repair contingency to cover for that. But they're saying that over the 5-year period, we need to buy 150 for $150 each. We need to buy 843. So we're spending the $126,450 for returnables. I'm going to go back to the expendable number and tell you, okay, so the packaging, and again, this already has the pallet in there. It doesn't, so they don't have to, everything is in this pack. So you're basically comparing this to a pack that has a pallet and a box and strapping versus this bin. So this is comparable to the entire expendable pack. Okay, so this is telling me over the 5-year period to buy the bins versus to buy the expendable packaging, you are paying $4,219,500 over the 5-year period. So that's a pretty big difference right there. So you're looking at over the extended period, even though they're only paying, less than $30 for this pack versus $150, you see the cost impact. Now let's see what happens. So we've got 4.2 million versus $126,000. Huge difference. But now you still need to understand what's the ongoing freight cost, what's the impact of this freight cost. So we went through that calculation. So part of the purpose of knowing how many parts go in a bin, how many bins go in a truck, and how many parts fit on a truck, besides for the schedulers to know, so the schedulers know how much they need and how much to order. Another reason is when you're working on a cost justification such as this, when you're trying to figure out the ROI and the cost benefit, you can take the shipments and determine, compare and see how much it's going to cost. So we already know, based on the exercises we learned earlier, how to calculate the number of bins on a truck. And we can take that and figure out how many over a 5-year period, we know how many they're running. And we can figure out how many trucks are going to be used during that period compared to how many trucks would be used for the expendable. Because remember, that expendable is only 2 high. This is going to be 3 high, you get more parts on a truck. So we can't just say apples to apples. We have to compare the two and see what it comes out to be. So, okay, so now we know that over the 5-year period, they're still going to need the 2.91 million parts. With the roll-pack bins, 1 truckload, we already know is you're going to get 2,520 parts in 1 truckload. So you can go back and compare that to those expendable calculations that we did to see, how many parts for one versus the other. The other thing, okay, so again, we're looking at the number of parts in the roll-pack bin of 2,520 from our previous calculation. So that lets us know that over 5 years, you're shipping 2.9 million divided by the 2,520 to get the number of truckloads. So you're going to get 1,155 truckloads over that 5-year period, which we already calculated over a 5-year period based on the different amount that you get on a trailer over 5 years for the expendable pack, which only holds 20 versus this one holding 30. And you get more on a truck. But based on that, you figure out how many truckloads you need. So you come out with 1,155 truckloads over the 5-year period. So you could take that same freight cost, which that rate that we figured out for this particular question was $625. So that is the exact rate that we use for the expendable packaging. For per truck, it's $625, no matter what. We just know that we have a different number of trucks because it's the expendable pack and the efficiency of that returnable pack. So we take that and we multiply the 1,155 truckloads, multiply that by $625 per truck. And that's going to give us a total cost of all of the trucks over the 5-year period that we're going to be using to ship the returnable pack. So that comes out to $751,875 for this example. So now we want to know what's the cost to buy those bins and ship them for 5 years, in that 9-day loop over 5 years is constantly. So again, we did the calculation. We know we have 843 roll pack bins. So we did that calculation up here where we took the number of the 729, which was just straight 9 days. We added the contingency of 10%, and then we added the half-day reserve to get the 843, just to refresh your memory. So now we're going to take that cost of the 843 roll pack bins, which we calculated to be 126,450. And that was taking that number that we knew we have a fleet of the 843. We know each one of these costs $150. So that's where we got the 126,000. So we know we're spending 126,000 on those 843 roll packs. And then we know that the cost for freight that we calculated for those 1,155 truckloads And we know each truckload was $625. So we take that 721, 875. So we've got the cost of the bins plus the cost of shipping those bins over a 5-year period comes out to 848,325. So just the flat out numbers, looking at calculating the expendable pack versus the returnable pack over 5 years. This is the difference. So again, to ship that returnable pack, it's 848,325. And remember when I said at the end of our lecture yesterday and the beginning of the lecture today, I said, remember this number, this 5,844,500. So if you compare that, that is the cost for the expendable pack, 5.8 million versus $848,000. So you're basically 5,800,000 and some change. So you can see there's like a $5 million difference over a 5-year period. So over 5 years, with the $5 million difference over 5 years, this is costing the company $1 million extra each year alone. Because if you take the $5 million, spread it over 5 years, it's $1 million extra every year. So I know that's not in your calculations or anything, but I'm just giving you some idea of an impact. So if you go into any company, probably any large company, and say, hey, I have an idea, one's going to save $1 million less per year than the other one, I think it's going to be fairly easy to do a cost justification for that. So I mentioned before that I'm going to have extra credit. Yesterday, I posted the video last night with Stephen Bueller, and I think it's called Steve Bueller Automotive History. It might be called Extra Credit or something. It's in the supplemental area. If you want to get extra credit, watch the video, pay attention, take some notes, and I'll give you some more information on what I'm looking for that. But he's talking about the history of when they first switched over, some of the things that were impacting the reasons why they switched over. But they had to go through this exercise of comparing the expendable pack to the returnable pack. So initially, if someone came in and said, oh, I want to spend $850,000 to buy some plastic bins, we're going to reuse them. That was probably a very difficult sell, because we're saying now we're paying $850,000 extra to buy this, to make this purchase, because this purchase is considered an asset. It shows up in a different part of the accounting system than something like this. This is considered expendable and it's considered an expense. So it shows up in a different area. So they don't necessarily add up over time what they're spending. So they just know, use this pallet, chuck in this pallet, $15 every single time, but it's just an expense. There's something we have to spend. They don't know. So one of the things that someone did was they said, you know what, how much am I actually spending throwing these pallets away and getting new pallets every single time? So that's basically what you did. You're like, oh, how much were we spending with this packaging that we're throwing away? So again, to walk into any company and say, I want to spend $850,000, but you don't have anything to compare it to, that you see the huge difference it makes when you say, if we don't buy these for $850,000, we're going to be spending $5.8 million. So we're spending $5 million more to ship the exact same parts. We have fewer trucks. We can get more efficiency, possibly protect the parts better, because you can see in that first picture early on, and I'll scroll back to that there was some compression failure. So, parts are probably coming out of here, breaking. So they're going to have, less spillage, less damage, ship more per truck, have fewer trucks. and spend a lot less. So you can see all the things as you layer these things in your ROI and figure these things out. So it can be very significant. And to come through and do this type of cost comparison and to be able to put all those things together, it can be very, very powerful. It can change the way you do business. So again, when you watch that video, you can hear about what the current state was or what things were like before they switched over. And then you'll get to hear, now you're seeing expendable packaging is only used for certain items. Returnable packaging in automotive is the default, and it's something people automatically assume because these people just know how much cheaper it is. So now you know how these calculations are done. And it's important to understand how to do these because even if you know you're not going to use expendable packaging and you're just putting together the numbers for returnable, it's important to understand that and be able to show that information. Okay, again, I mentioned already benefits of less damage, right? There's also the labor involved. So you're going to see more about the engineering services in there. And then also the interest on borrowed money and taxes. So when companies make purchases and capital expenditures that are, a lot of money, they well, it'd be interest involved. But also we may not notice it or think of it this way, but the money that they're using to buy expendable packaging, it's a one-time use and it's put in as an expense and not necessarily tracked the same way. It's not tracked the same way as an asset would be tracked. They still could maybe consider this a cost of doing business. And depending on how the company is structured, they might borrow money because they know, okay, we have this business and maybe we don't have the cash at the time, but we need to have these pallets. We need to have this packaging to ship. So they will borrow the money and pay interest, which is going to reduce their profit versus, buying this. So if you're spending millions of dollars to borrow money to buy packaging that's expendable versus $500,000 to buy packaging that is returnable, that even once this is over, you might actually get to use it again. That adds up with interest. It's kind of like when you buy a car, pay it off early, buy a house, pay it off early, you pay so much less interest. Or you have a credit card. If you pay the minimum on you get your credit card and you pay your minimum of $30, whatever it is. And this happened to me when I first came out of school. I got a credit card and I think I bought like a couch or something. And when I bought this, it was maybe $300. Not a big deal. I could have just bought it, but I'm like, I have my credit card. It's great. So I take my credit card and I buy this couch and then I get my bill and it says, oh, pay your minimum of $25. So I have a $300 credit card bill. I pay the minimum of $25. I get my bill the next month and my bill was like $310. And I'm like, well, I only paid $300 for this couch. And I paid what they told me to pay, but the interest on that was so high that now I actually owe more for this couch than I planned on paying. Same type of thing for large companies. They want to reduce the amount of interest that they're paying on what they're borrowing. And then even like taxes, this can affect their taxes as well. So there are a lot of different things, but now we're going to do the return on investment calculation. So I try not to digress too much. So, okay, over the 5-year period, the cost to continue implementing the existing packaging, again, was the 5.8 million, 5.844, 500 to be exact. Okay, the cost for the returnable program is 848,325. So if you put this under here, look at this. 5.8 million, and maybe I'll get fancy and not sharing my screen. I'm so sorry. My screen disappeared. Okay, so we're gonna go through this again. Sorry about that. Go through this real quick because I realized my screen disappeared. Okay, so you figured out that you added your fleet for the 843, multiply it by $150, you get $126,000. You figure out over the 5-year period how many parts you have, which you were given already. From there, you figure out how many your other calculation you did to know you needed 2,520 roll pack bins. And then over 5 years, you're going to take the 2.9 million parts divided by the number of bins that fit on a truck to come out with 1,155 truckloads. The freight cost for each one, again, is the 625. So what you're going to do is you're going to take the number of truckloads times the cost of each truckload and come up with 721,875. Okay. So now you're going to take the cost of your freight plus the cost of your roll pack purchase. And that's where you get the $126,000 for the cost of those 150 bins. I'm sorry, for the $850 bins, 843. So the cost of your returnable bin purchase is 126 plus the cost of your freight over that 5-year period is 721,875. And that's where you come up with the 848,325. Okay, so again, we talked about the cost of benefits. You've got labor, you've got less damage, which I already mentioned, and the interest on the money and taxes, which I talked about, my wonderful credit card experience. So this is where we calculate the return on investment. So now we're caught back up so you can see. Over the 5-year period, you know that the expendable packaging was at $5.8 million, right? I was going to annotate here. This is when I realized that I was just talking. Okay, so you could take this, look at this, 5,844,500, okay? And then the cost for the returnables is going to be, and I'm just going to put it under here so you can see, 848,325. So if you compare those two, look at this. This is slightly over $5 million more. So if you're just doing a real quick number, it's like $5 million difference between the two. Okay, so this is where it says clearly using returnables is more profitable. That's why we put them under each other and you look at the difference. If you just look at these two numbers, it's a huge difference. So that money can be used for other things, right? So it helps make the company more profitable and you can use it for other things. Close this. Okay, so what you can do to make your calculation, the profit, again, that's where I showed you the profit, where you take the 5.8 million, 5.844,500 minus the cost of the expendables, which was 848,325,000, and you're going to get 4,996,175. So again, that's where I was like in my head doing this around, $5 million. But look at this. This is less than $4,000 under $5 million. So you take that 5.8 minus 848 and you get $4,996,175 that the company is saving over a 5-year period. So what you can do to calculate your ROI, you're going to take your profit that we just calculated here, divide it by what you want to, what you're going to spend, which would be that returnable pack. And when you take that calculation, you come up with 5.89. Okay. So your return on investment is 589%. So it's a huge return on investment. Many projects that companies work on, not just automotive, but many companies, when they're working on it, the return on investment will be much lower. And the requirement for them to say, okay, this project is a go, could be much lower. So this one is something that is going to be a no-brainer for most organizations, even if they're going through a really bad downturn and they don't have much cash on hand, they're going to want to spend most likely, you know, $850,000 on some packaging. Now, if the company's doing really, really badly, they might say 589% return on investment is not enough. And so you have to understand what that threshold is for each company. It's different in each company, and the financial status of each company, the economy, all those things come into play. But once you put this whole calculation together and you come out with this ROI number of 5.89, or you can also say 5.89, 589%, either one. This gives leadership a guide to whether or not this is something they want to pursue, because they might say, we're not going to fund any projects that don't have a return on investment of less than 3. Well, this one is 5.89. It's well over that, right? It's almost 6, it's almost double. So they're going to say, okay, it meets the requirements. Or they might say our return on investment has to be 1,000%, or 10 in this case, right? So then it wouldn't qualify, but more than likely, you know, this is fairly high. So unless the company's going through really, really rough time, something like that's going to go through. Okay, so that one was a very simple one, so you could see how things work, and it was very obvious, you know, that there's a huge profit, you know, huge savings, and helps with the profit of the company. So usually, you know, you're going to have the same bin that might be used for more than one part. And this might actually go to other plants too. So when the OEM is looking at this, the OEM is going to look at how can I use this bin for multiple locations, and multiple parts, and spending, because then they might get a discount. You know, they might $150 for something like this tells me that this company has a pretty decent negotiated discount, right? Okay, so there are, you know, a lot of things to look at for this. So you're looking at things like cash in and cash out. This analysis is showing you, okay, this was completed 12 to 18 months before production parts were manufactured. It became part of the documentation behind the ROI calculation. So there will be details here. A lot of times you see this information, and it's important for you to kind of see this and understand that these numbers are out there. But one of the things you want to do is to be able to recognize the numbers that really relate to packaging and can impact your return on investment calculations for returnable packaging. So this is just showing you how complex it can get. And I've seen spreadsheets that are, okay, my hands are going out of the screen, but I've seen literally spreadsheets that are like 100 items across. And it includes not just packaging, but it includes different parts and locations and all kind of information, different lines and different materials. And you might have like, say, door handles in different colors and, you know, all kind of things. So it's just, you know, it could be very detailed. So this is why, you know, I want to show you this so you can see it, but remember that what's important is you figuring out and being able to recognize the items that packaging needs. Okay, so this is a wonderful bill of material, a BOM, right? And sometimes you might hear an E-BOM, but generally most companies refer to it as a BOM or bill of material. So this gives you a list of all the parts. So like, for example, when I worked for a seating plant, all of our bills of materials had every single part for a seat. So you might have the passenger seat and the driver's seat or the bench seat in the back. Those were, and include everything from seat belts and leather. It could have cup holders, whatever, that would be on the list. An assembly plant, they're gonna have everything from the engine to the doors, to the windshield, to the seats, to the headliner, which is that part that's when you're in the car and you look up and it's the cloth that's between you and the roof of your car, trunk, all the different parts that would all be listed on the bill of materials of the BOM. Okay, so for this one, packaging engineering is saying, with a couple other departments that, I like this, it says that several departments have been working together. So that's always wonderful. That's why it's really important to have a good relationship with your manufacturing team and your program management, your finance and your purchasing, everybody, because when you work on something like this, it is very helpful for everybody to be on the same page. I can tell you, I have a client right now that I'm working with, and the part engineers, they know the bill of materials, but no one else has access to it because they're like, oh, you don't need that right now. But actually, yeah, I do. I kind of need to know what part's going to be packaged. So let's see. I have, okay, this list here, I just kind of want to go through here. This is pretty typical. You're going to see like your description. This is probably, okay, this looks like the length, the width, and the height. So this might be packaging. Every company will be different, but you can see that these are all like different things that are important for that particular part. Okay, so this shows like a density, this shows like the type of truck, parts per day, containers per day. So these look like they're mostly packaging type of pieces of information that you would need. So when you look at, I just also want to mention these particular departments, right? Departments will have different names in different companies. So material handling, those are going to be the people. So you see the people that are driving trucks around and they're unloading the trucks. The people that drive fork trucks, or people that drive any sort of little vehicle or hand trucks around the plant. That's usually material handling. They're the ones that are going to like bring the parts to the line, pick up empty containers or pick up trash. They're the ones that they're literally handling material. They might be called tuggers or drivers or fork truck drivers, but they are all part of material handling. Engineering is going to be usually people that are designing the parts, or people that are working on the equipment or the layout of the floor. So like the people that come up when we watch the Rouge video, the people that came up with the plates or the skillets that were moving the parts, that would be part of the engineering team. The people that come up with the order of the line, say which parts should be kitted, which parts are going to be put on the vehicle first, and which parts are going to be put on last, and what station is that going to go. That's also going to be engineering. And then the people that actually design the parts and work with suppliers to make sure that the parts work, that's also engineering. So that could be any of that. And then you got packaging, production control. You might also hear production control as like master scheduling or schedulers. They're the ones that are following to see, are we getting enough parts in? Are we getting the right parts in? Are they coming to us in time from the right supplier? That kind of thing. Logistics, that's going to be, the people that are dealing with the trucks and the shipments. Sometimes packaging falls under logistics or supply chain. Sometimes packaging is its own department. It just really depends. And then you get a lot of other disciplines, like you've got the manufacturing people, they might come under production control. It just depends. So those are just some examples. So you can see this is an example of the bill of materials. However, you can see that all these different teams need to know this information and they need to understand what the packaging looks like. Let's see. So, okay. Okay, so here's some abbreviations. Okay, so we got the description, right? So there's usually they start off, when I've seen mostly they start with description. The pecan is length, width, and height. That's the number of, okay, it's the number of parts to fit in the primary container, which I kind of was thinking that's what that was. And then you got the density. Oh, and the P is for the primary container. And then you got the secondary container. So you've got, like for this, for example, this could be a tray or a bin. This could be an outer box. This could be, okay, let's look at this. For example, okay, so this one, the density for the primary container is 60. So that could be a tote, it could be a bulk bin. This density, that could be a full unit load, it could be a pallet full, it could be a bulk bin. I was trying to see if there are any in here that are the same, and it doesn't look like it. So the second container density is generally going to be some sort of pallet, most likely. That's what it looks like. This also shows you like how many parts per day. So you get here, you've got 1,000 parts per day. The secondary container is 480. So that tells you that you're going to need probably a little bit over 2 of these. You're going to need 3 of these a day, right? This one, they're using 10,000 parts a day. And this container is 18, the pallet, I think this is unit load. You're using 1,800 per unit load. So you're going to use like 6 pallets of this a day. Because if you do 5, you're not going to get to 10,000. Because you would need 2,000 on a pallet. So you start doing this stuff in your head after a while. So I don't want to add too much, but I'm just kind of showing you how this works. Let's see. And then you also have in here that, okay, so this is what I was saying here. The secondary container is a container that holds the primary container. But in cases where parts are directly loaded into containers like roll packs, the pecan equals the SCON, which that's what I was trying to see if any of them match. I don't see any here. Yeah, so this tells me, that's what I'm saying, these look like they're all maybe totes. If it's an expendable pack, it would maybe be a small box or a tray, and then that would go into like a pallet or unit load. And every company is a little bit different on how they do this. They might have, other breakdowns of how they want their packaging to look. So again, this is a guide. This gives you an example of what some of these things look like. Again, this is just showing a little bit of packaging information, but these spreadsheets can be huge, just out of control. But you won't need to know like where your part is so that you could just maybe work on this, pull the information from those columns. And you also want to find out, a little tangent here, you want to find out who is responsible for this. This looks like part of a PFEP, the BOM, a bill of materials, and then there's a plan for every part, or PFEP. That's what this looks like, part of it. So if you want this section of packaging to be together, because I've seen these types of spreadsheets where you've got like your primary container information, and then you've got a bunch of other information like what station it's on and all this other information that's not necessarily like relevant for you at that moment. If you can get all the packaging dimensions and quantities in the same spot on the spreadsheet, that's always great. So this is another reason why it's really good to have a good relationship with the team members, because then they will do things like that and not think anything of it. Okay, so for this one, you're assume that the primary container is a tote, and then the secondary container is the unit load, which is going to be that pallet with totes on it. Tried to get some mini totes, but hopefully next semester I have that. So you have this pallet and you have totes on this pallet, right? Or trays or whatever that primary container is. In this case, it's a tote. And then the secondary container is going to be this pallet with all the totes on it. Okay. Second part in the BOM we're going to look at, which is, it looks like some sort of headlamp bezel. So you'll also learn some of these terminologies and descriptions. You'll see things like bezel, this is a lamp. So I know this is most likely a headlamp. I'm just assuming that. So yep, it says bezel, and it's just a cover for a headlamp. So you can see here, we'll go back and look at it, but that primary container is saying it's 10 by 10 by 10, and it holds 100 of these. Okay, this tells me that this is probably an expendable pack, but that's a whole other story because it's not falling into the automotive standard. So you've got, this is 48 by 45 pallet. If you look at this, it's going to be, you're going to get like 4 in one way, 4 in the other way, and then you're going to have 5 inches on one side of the pallet, and you're going to have 8 inches on the other side. So that I just know, because I talk about all these standard totes, like we look at that Orbis catalog or that Bradford catalog, they're all like 12 by 15 by 9, or they're divisible by 48 or by 45. So 10 is not divisible. You can't divide 10 into 48 or 45 and get an even number. So this is telling me personally that it's an expendable. So these are just the things that you'll learn after a while. So then the secondary container is a 30 by 30 by 28 inch unit load. So it's going to hold 18 totes in 2 layers and 9 totes per layer. So it's going to be 3 by 3. So based on that, we learned earlier how to calculate how many parts are going to be on your pallet. But again, the secondary container, which is considered a unit load, it comes out to 30 by 30 by 28. And again, we've been talking all the way through this, that this standard automotive pallet is a 48 by 45. And the standard bins are 48 by 45, right? So when I see something like this, this kind of jumps out at me. So let's go back and look at item number 2. Again, bezel headlamp, right? Primary container, 10 by 10 by 10. The density, 100 parts. The unit load is 30 by 30 by 28. And you get 1,800 on there. Okay, and then on a truck, you get, a pallet, and then they're using 10,000 of these a day. So that means they're using 100 containers a day, right? So after a while, you get to start looking at these and you can see, okay, which ones are, okay, so here, this one is using a 48 by 45, but it's a 68 inch height. So, when we looked at that height of 106 inches, you're not going to really get 2 on there. So I'm going off on a tangent right now, because this is how, once you start looking at this on a regular basis, you're going to be able to look at these and pick out the ones that are off. So for example, and the 68 is really tall. That tells me it's a big part. So yeah, it's trim. So it's a really big part. Trim is going to be something that's really huge. So that's probably why they have these odd shape. This is an odd container. It's very tall. But then if you look here, look at this one. The unit load is 48, 45 by 48. So it's a standard automotive footprint, and it's 48 inches tall, right around that 50-inch unit load. That's kind of what you aspire to. For too high, you can go too high with this one. This one's 52, you know, you go too high. This one is 48 by 40 by 70. That's an that's a grocery pallet. So, you know, this is me going on a tangent. You can already see on some of these, you can drive some of these towards automotive standards. So that's like your first clue. If you're looking at doing an ROI, first clue, I can standardize these with automotive packaging and make sure your calculations actually more straightforward and easier, because you're plugging in the same thing. Now you're plugging in same sizes, but now what's different is the number of parts and their usage, how many they use. But as far as like how many of these bins go on a truck versus how many, you know, or pallet loads go on a truck, you can figure that out. You know, you'll have standards. Okay, so we did that. This bulk pallet rack identifier, so a lot of these companies have warehouse management systems or WMSs, and the WMS will tell them, like, based on how much inventory they have, based on the part, they will be dedicated to certain areas of the warehouse. So maybe these parts, these really big bins, they know they can only fit them on the bottom row of any rack. Or maybe anything that's coming in as a kit, they know is going to be, there'll be instructions in the WMS to take that over to the supermarket for kitting. So the warehouse management system should be directing the material handlers where to put things or where to find things. When they actually go to replenish, when the tugger drivers go to replenish, they can look in the system and tell where they need to go to find these. Sometimes they're dedicated, it's always going to be in the same position, and sometimes they put it in where they have room. And if you have a system that's just putting things in where there's room, that's another reason why having standard pallet sizes will be important. Because let's say that, you know, most of your bins are this size, and you assume it. You set up your racking to hold this type of bin, but then something comes in that is an odd shape, then, or it comes on, you know, one of the pallets that isn't made to sit on the style of racks that you have, then you can have some of the issues, because the warehouse management system is only going to do what you tell it to do. So another digression. So again, that pallet rack identifier, it assigns to the warehouse storage space, and this depends on how your system's set up. The PLT RCK, it tells you it's a pallet rack. So let's look here. See, these are all showing you pallet racks, that these all get stored in a pallet rack. So this is something that the material handling group would be looking at this and say, I need to get, you know, I need 10,000 of these a day. So they can see I'm going to need pallets, the 1,800 per pallet. And I can find these in the racking. So when they go to replenish, they know I need to go to the area that has pallet racks. And then they'll usually have some location I can address for them, so they can find it very easily. That also helps from a packaging standpoint, because then you know what kind of packaging to have, because then you know what your space limitations are on the rack, you know what your constraints are, but then you also know if this is going in a pallet racking, I need to have a pallet that will fit on that pallet racking, or is made for that pallet racking, or that can handle storing parts on that pallet racking. So that question we had earlier in an earlier assignment about, you know, which types of pallets can you use and which types of pallets don't work in racking, this is exactly why. So the pallet racking is good because it's standardized, and they can use fork trucks to get the parts. They can also, you know, standardize their packaging, so they know that the packaging has to fit on these racks. So for example, if you've got a certain rack, this tells me they're probably using something like this. It's smaller, But if the racks are made to hold this and then you put this on a rack, it's not going to fit. It could fall through, for example. Just giving you an example. Okay, so it says all the parts are showing pallet rack, which I noticed, but sometimes it might say something like bulk. So that means that, you could find, storage spaces for bulk bins there. And they might be stacked on top of each other. If, instead of being on a rack, they might have space on the floor without racking because they know that these can be stacked. I forget how high, but if you look at the catalogs for Orbis or Bradford, like we did in that one assignment, it'll show you like how high you can stack these based on the weight capacity. And then you saw like the dynamic and the static compression. The static is going to be how many you can stack high on the floor in a warehouse situation versus the dynamic is when it's moving around. So, those things all come into play. So you can look at this and see that, if it says bulk, it could be, somewhere there'd be a bulk area that's dedicated for parts that go in bulk bins and they're stored there. And then again, it's a good point, the plant safety policy. So you might be able to stack these 4 high, but some plants, the sprinkler system will be maybe only what would be equal to 3.5 high. I'll just make it easier. Let's just say you could stack these 3 high. But when these are stacked in the warehouse, the sprinkler system may be right here. So if there's a fire, the sprinkler would spray on top of the 2. But if you put a third one on top, and now you're here, your sprinkler system, instead of being here, now your sprinkler system is here. So if there's a fire, these would catch fire and not ever get extinguished. So that's something else to know, that a lot of times, because of the fumes of these plastics, the fire regulations are going to come into play. So that will also determine how you stack these and how high you can stack them. So you hope that your team that laid out the plant put the sprinklers up higher. Okay, so that's where it talks about the plant safety policy there. Okay, parts per day, it shows how many parts are going to be used daily. So that's where I was saying, this part they're using, 10,000 a day for that bezel lamp, that headlamp bezel. What else is in here? Containers per day. It's the number of primary containers you're using. So for this one, containers per day, they're using 100. So what did they do? They took, in this example, you're going to take the primary container density, round it up, and then divide it by the parts per day. The unit load per day, unit loads per day is the number of the unit loads that they need to handle every day. So again, you can see here, it tells you the number of containers per day. This one is 100. And then, so you can see here, so basically they took the 10,000 here, divided it by the density to get 100, and then unit loads per day. They're looking at how many they're doing per day. So that's based on, again, that secondary container, the unit loads. So you're going to take the number, your density, and divide that by the parts per day. So let's look at this. Your SCON density, which is your secondary container, 1,800. And then you divide that by your, let's see, make sure I have this right. So number of parts per day. Okay, so we're taking the 1,800 and then dividing it by your parts per day. Doesn't sound right. Doesn't add up. Parts per day by the S-con density. Okay, I'm so sorry about that. Your S-con density, which is 1,800. Minute. Okay, so we're going to take the S-con density, which is 1,800, and divide it by your parts per day. It just doesn't sound right to me. Okay, unit loads per day. So all right, so next you're gonna make sure it's rounded up. That might be why. So okay, this gives you an idea of like how much space you're gonna need. So remember early on in chapter 1, we talked about making sure you have enough space. Because we have, on average, you have 400 truckloads coming in, but regardless of how many you have coming in, you just want to make sure that you have accommodated and accounted for how many trailers are coming in, how much material you're using, and how much material is going back and forth and being delivered and empties picked up at any given time. So there's a lot going on. So you basically want to look at your whole supply chain and the whole manufacturing process. You want to look at everything, and all this actually comes into play. So that's why you're taking this looks like it's not much information, but it can be used for a lot of different things. Okay, so now we've got the expendable packaging program. You've got 3 different diagrams that you're going to look at, and you're going to figure out what we did before. You're figuring out which arrangement of containers is best. They use Q by Q for this. Most people, because if it's standard, you have your standards already with, say, like Orbis or Bradford or Ropack, so you already know how many fit on a trailer. But if you're using other items that, other packs that aren't standard, then something like Cube IQ comes in handy. I know they have the same thing for things like tops and cape, but this is how this was figured out. Okay. So if you look at a load like this, these are all these different colors of different parts that are being shipped on the trailer. So this is pretty typical of a load that would be coming from a distribution center or a center that is cross-docking, because they're putting multiple parts on it to ship to the assembly plant. So these are just some arrangements that you can look at to understand. And this is what the people that are loading parts to ship to the assembly plant, they would be looking at these sorts of arrangements. But it's good for you to understand why it's important. If you have like modular packaging or standards, it makes it so much easier for these calculations. And they don't have to really think that much about it, because they know if everything is coming in either 48-45 bin or on a 48 by 45 pallet, then it's just going to be a matter of, they can figure out how many go on. So they can say, okay, well, I only need 3 of these today, but I'm going to need like 5 of these today. And then tomorrow I'm going to need 4 of these, but I'm going to need 7 of these. It would be easier, because now they're just multiplying, 7 of these or 5 of these or 4, whatever that amount is, onto a trailer, because they already have that set footprint. So they know they got to get it up to, say, 52. If it's a 48 by 45 pattern, they know they're going to, look to get 13 per, 13 per row. And then it's like how many high are they stacking and how many high across, how many two across. So these are just some examples of that. And these are part numbers. That's why I can tell that you look at these different colors and then you see a number of these are part numbers. So let's go back up here again. And this doesn't have a part number on it, but if you were to take this whole sheet, you would have a description and a part number. So these part numbers that we just showed before, they would always tie into the same description. Let's see what else can I tell you about these. Okay, so they mentioned here a hot load, right? A hot load is basically, this is something that's needed right away. So I think I mentioned early on, I kind of referenced a helicopter. You don't want to use helicopters. But a hot load is something that they know is something that they need right away. It's been maybe it's expedited, or maybe they knew it was coming and is due to come. But if it's just in time, they don't necessarily have anything extra sitting, or maybe they've gone into their 4-hour window, they're within their 4-hour window of materials. They have less than their half, their half day, their half shift, or whatever that number is that they've determined for their safety factor. They've started to eat into that. So now the load that's coming with the materials that they're going to need soon, or they need right now, it's called a hot load. And then that people know a hot load's coming, and then they can, go and address that. And the material handlers or the truckers or whoever's moving those parts, receiving those parts, they will address those first. So make sure there's a dock door open. It's a whole thing. Dock doors, we don't need to talk about that. Okay. So this is something like for the milk runs. I mentioned the milk runs where they're maybe running truck, dedicated truck within a shorter distance, and that's called a milk run. This is the kind of information they need so they can figure out, how do they load this, what's needed. If you have modular loads and everything's the same size, the unit loads are the same size, it makes it a lot easier for them to figure these things out. Okay, so now we're going to talk about this proposed program. So now that was just giving you some background about looking at the information. It's a lot of information. How do you decipher what some of that information means, and how do you use it? That's why I was saying it's important to understand what these pieces of information mean, so you kind of know which ones you could use, which ones you will use. Okay, so this is an example of a proposal. You can see the total cost of buying the containers, and then they do the same thing for all the part numbers. So you'll see, this one parts per container, you got 30, 80.83 required, number of days in the system 9, total containers 7.27 or 728. I'm going to round this up. They added, for this one, they added 3% for their repair contingency. Now, remember, in that simplified version that we had, we used 10%, but this company, they believe they have a much tighter hold on, what gets repaired. Maybe their maintenance is pretty good. Maybe the parts aren't heavy and they're not breaking anything. Maybe they don't necessarily use a lot of fork trucks, or maybe the fork truck drivers are really experienced, so they don't break as much. For whatever reason, they've determined that their repair contingency is only 3%. So based on that, they've determined that they need 750 containers for their fleet. Again, they've got that same 9-day fleet for days in the system. So this is how they determine what their fleet is. The containers cost is the same, $150 per unit, per roll pack. So they're taking the 750 of these times $150 per bin, and they come up with $112,000 is the budget that they've estimated they need to have 9 days of containers, 9 days worth of containers in the system, based on their volume, based on their jobs per day, all those good things. This is their returnable dunnage cost, 3 times expendable dunnage. So this is the dunnage. So for example, let's say that they want to use some dunnage to go in here. Maybe they're going to use a corrugated insert. That would be an example of expendable dunnage, right? But they already know, let's say the current pack is using a corrugated box with corrugated dunnage in it. Now they're saying, let's replace that expendable box with a returnable bin, and we're going to put expendable dunnage in there. Or sorry, returnable dunnage in there. Okay, so this is saying returnable dunnage that goes in here is $10.47. And they made a note here, just so people know that the cost of this is 3 times the cost of the expendable dunnage. That's important to know for a couple of reasons, because maybe they determined that instead of, for whatever reason, some use a combination of returnable packaging with expendable dunnage. So it's important to know that they're telling you a piece of information you might need later. The returnable dunnage is $10, basically $10.50, while the expendable dunnage is going to be $3 and I don't know, $3.15 or something like that, or $3 and maybe it's $3.20. I'll just round it up, just rough estimate. This also tells you that they're going to need 5 pieces of dunnage for every bin over the next 5 years. So what they're saying is they think that after probably a year that this dunnage is going to have to be replaced. So they figure that for every returnable bin they buy, they're going to have to buy 5 of these through the life of that program. So however you want to do it, but that's what they're estimating, because even though it's returnable dunnage, it's not as durable as the bin itself. So those are things you have to keep in mind. Some of the dunnage stays with the packaging, the returnable packaging. Some of the dunnage is thrown out every time, but that's something you need to know and put into your calculation. So based on this, they know that the investment for the dunnage is going to be just under $40,000. So they were able to say their usage. So well, this took their usage for one over 5 years. This is going to take this times 5 over their usage over 5 years, and that comes out to $39,000, $262,050. $262, I'm sorry. So the returnable container investment is going to be the $112,500 plus the $39,262.50. That is going to come out to $151,762.50. That is going to be the cost of your returnable packaging for this program that you're proposing. So again, that's going to be basically 1 of these, 5 of these for, and then multiply that by your usage that you calculated before. Okay, this gives you some information here. It shows you that, where this came from. This shows here is provided by manufacturing engineering. Again, this is always a really good time to be friends with your manufacturing engineers. So you can make sure that they, if they're responsible for doing these calculations, you want to make sure they have the right information and they're just not making things up based on previous assumptions. You may have information that will help them because an example, maybe this bin, it was $150. It's been $150, but now after the pandemic and the resin shortage in Texas a couple of years ago, prices have gone up. So now maybe this bin is $160. $175, whatever it is. Still, return on investment will be good, but that's just a really good piece of information for whoever is doing that final calculation, whether it's you or someone else. They got some dimension information in here to explain this to get to, oh, this is 30 parts in here. This tells you how they got to this. They're going to explain that later. So what they did basically is they showed their work. They showed their calculations, because leadership, they will want a summary right here, but then they might go, well, how did you get this answer? What was your calculation? So you know how we're into always telling everyone, show your work in your homework, because that's basically what's going to happen. If you put together a presentation and you just give people a bunch of numbers, someone's going to ask, well, how did you come to that calculation? So they put the explanation next to it so you could see it. And then just some basic information like this price. So they're saying where their price came from. This came from purchasing. So this is telling leadership, we're giving you this calculation, and we know that this $150 is accurate because purchasing gave us that information and confirmed it. This tells you how they came to this calculation, $750 for the fleet times the cost. This is what they estimated, and that's in a different section. This is based on the number of working days per year. They figured out that it's 9 system days, and they figured out how many turns per year. So that's telling them how many times they're going to reuse this a year. And then they took their cost. Okay, so 273. So they took $2.73 times 750 times 5. Okay, so I just want to look at that really quickly here. That's probably me, 1047 divided by 3. Okay, so that's $3.49 was this cost, to be 3 times the expendable. The 273, I'm really curious how they came up with that 750. Will come, that's going to be lower down. So this again is adding these two together to get this. Jobs per day, that's how many cars they're going to make a day. So that's in the case, it's right up here. This tells you it's coming from the manufacturing engineering or industrial engineering. Depends on, you know, the company and who holds that information. Parts per container, that's your parts that are going to fit in that roll pack. So this is where we talked about, you had 20 parts in the expendable pack and 30 parts in the returnable pack. Containers per day, we calculated that already. Number required in the system. Their repair contingency is 3%, we mentioned before, and they took that to get 750. So again, they calculated that 80.83 or the 81 total containers, because they're using basically 80, just under 81 containers a day. They know they have 9 days in the system. So we're basically using those same numbers that we used in the last example, except that the repair contingency is now 3%. So what they did was he took 1.03 times 727. So what that does is, by doing the 1.03, you're basically you're saying 100% of my containers, which would be the 727.5, is the 1. This equals 1%, and then the 0.03 is equal to 3%. So if you just do 3, and then you hit the percent, you're going to get 0.03. Okay, and then if you just add 1, you're going to get that 1.03. So that's how they came up with that. So they're taking, so this would be the same thing as saying 0.03 or 3%. Let's do that again. So yeah, that's the same thing. So 3% for your repair contingency, and multiplying that by your 727.5, right? And you're going to get 21.825. Okay, now we're going to add that back to the 727.5 and then come up with 749.3. So it's slightly different, but you can see basically what they did was, instead of going 727.5 times 3% and then adding it to the 727, another way you can do that is just to say your full amount, the 727.5, and then multiply it by 1.03, because that's basically, you're saying the full amount plus the 3%. It's the same thing. You're going to come up with you should come up with the same number. Okay. And then you've got your returnable dunnage cost. Okay, so they're using sheets of corrugated that's in the roll pack, and it's just separating your parts. I'm sorry, it's cold in here. I always yawn in my cold, so I'm not boring myself. I might be boring you, but I'm not boring myself. Okay, so typical locations, they're going to work the 250 days a year that I mentioned before, because you're taking out like weekends and holidays. So you're going to take out 365. You're going to have your 52 weeks. So you have 2 days that are weekends for each one. So now you're taking the 365 days out of the year. You're subtracting 52 times 2, which is 104. So now you're at like 314 or something like that. Just do it in my head, probably not right, but now you're going to take out your holidays. So by the time you take out all the holidays for shutdown and all that, you're basically going to be at 250 days out of the year. So, okay, so you're going to take your 250, which is your number of working days, and divide it by 9, which is your system days, right? So that's going to tell you, 9 days, again, that's that number of how many days it takes for this one bin to circulate and come back. Okay, so you're going to take the 250 days divided by 9, because you're saying, okay, so this takes 9 days to circulate. How many times is it going to take to circulate in a year? So according to that, this is going to make that round trip 27.78 times. So I like this sentence here. This means, so you round up to 28. There are 28 opportunities per year to misplace loose dunnage or damage it. So that's why they say they want to replace that. So again, I mentioned before that sometimes you'll see some of this dunnage and it will be like it's in and you can't get it out. They might put it in with fasteners. They might use Velcro, but they might do something to keep this from coming out. So right now this comes out. So what happens when you get a hot load? They need to load this hot load. You know what? This particular one, it's got this dunnage in it. We don't have enough containers with this dunnage. You know what? We got some extra dunnage here. We got that replacement. We're just gonna put this in here and use this instead. Now, this dunnage, it doesn't get put back neatly in place. If we could use this later, someone walks by, a cleaning person walks by, and this is on the floor because it's a hot load and they're rushing, they just throw these out. The cleaning person comes by and takes it, or somebody goes, ooh, I can use this for something else. So it's gone. So that's why they plan on buying extra dunnage, and they're gonna have to replace it. And they figure out that they probably have to do it like 5 times over the life. And so here I mentioned If you got 5 years, they plan to replace it once a year. Okay, so the investment for the dunnage, again, that was at 39,262. So they took that 750, which is your I'm still trying to figure out where they came up with this. 50 times the $2.73. I think they spread that out. So over 5 or something. But anyway, so they figured out that they need to spend $39,262.50 for dunnage. And again, they added the 112,500 for the containers, plus the 39,000 for the dunnage. And they came up with 151,000. So that's what this is here. It tells you here. It's also showing you the calculation down here as well. Okay. All right, so these are loading diagrams again. More loading diagrams. So this is saying these are stacked 3 high in transit, which is that dynamic that I mentioned before. So you see they're three high in the truck, but they expect there to be some movement, which can impact the strength of those containers. But when they go to bulk storage in the static where they're not moving, these could stack based on the weight of the product and the capacity of those containers. They could actually stack them 6 high. Okay, so let's see. These were just some other examples. You can see here the different color coding and part numbers to show you what these different parts are, how they're stacking them in these loads, how they might stack. Okay, so now we're going to do another example of return on investment. So for return on investment, I'm gonna have to pause for a second.